interested here in finding the ratio between the two radii of the circle and then the semicircle. Somehow we've got to connect these into the problem. And we're also told that AP is equal to PO, or PA equals PO. Right, so these are the same length. And that's going to be quite useful because actually this length here is, I'm going to call it capital R. That's the radius of the large circle. And so if I draw a line coming down, then this length here is going to be a half r, or r over 2. Now I can immediately also write little r, that's the radius of the small circle. So I've managed to create a right-angled triangle where I have two of the lengths. So what if I could work out this length here? In terms of, I know I can work it out in terms of r and r over 2 by using Pythagoras' theorem, but can I get there some other expression for it? And you can, because if we look at this, then this length here, or the full length I should say, is going to equal r. And then this length is also little r. And so the missing one is going to be the difference between those, r minus r. And I'm going to draw this triangle away from everything so we can just visualize it a little bit better. So we've got this height of little r, we've got the base of r over 2, and I've got the hypotenuse, which is capital R minus r. That's probably the trickiest bit to get, but I hope I've explained that adequately. So now I can use Pythagoras' theorem. I'm not going to use any square roots. I'm just going to say that r squared is going to be, r squared plus r over 2 all squared is going to equal r minus r squared. Right, that I'm going to come over here so there's a bit more space. R squared plus r squared over 4. It's a double bracket. Don't forget that. It's r minus r times r minus r. So I'm going to get r squared. I'm going to get a minus r and then another one. So it's going to be minus capital R times little r plus r squared. Okay, these cancel. Brilliant. And we can sort of see now. We're going to try and get a relationship between capital R and little r. I think I'm going to multiply through by 4. You could do it using fractions, but that's what I'm going to do here. So that means we're going to get 8r is going to equal 3r squared. Cancel out the capital R's, and we're nearly there. 8r equals 3r. So that means that r is going to equal 3 over 8 capital R. Now, we're interested in the ratio of the radius of the circle, so that's the small r, to the radius of the semicircle. So what we could do is just substitute in for little r, 3 over 8r, or vice versa. So this is going to cancel down to 3 over 8 to 1, 3 to 8. And that's our answer. I think once you get the 8 over 3, you kind of know it's going to be b, but I'm just trying to explain where it comes from. There's different ways to consider it. But basically, yeah, because we can see that capital R is 8 over 3r. There's lots of different ways, but you might be able to go straight from here. In any case, the answer is 3 to 8.